Changing between logarithmic and exponential forms. If x is greater than 0 and b is less than 0 but less than or equal to 1, then y equals log b of x if and only x, b to the y is equal to x. We are going to use this to evaluate the following logarithms. And all you need to remember is that a logarithm is an exponent. So if it's asking you for log base 2 of 8, what it is asking is, what exponent do I put on 2 to equal 8? So 2 raised to what power is equal to 8? If you think about it a second, you would say 3. For our second example, they are asking you, my base is 3, what exponent would I put on 3 to get the square root of 3? And if you recall, the square root of 3 is the same thing as 3 raised to the 1/2 power. So that pretty much gives me what my answer is, which would be 1/2. For our third example, 5 raised to what power is equal to 1/25? Well, since we haven't moved to the bottom of a fraction, we know that it's going to need to be a negative exponent. And 5 raised to what power gives me 25? Well, that would be 2. So 5 to the negative 2 would give me 1/25. For the next example, 4 raised to what power gives me 1? Well, what raised to any power gives you 1? Think about it really hard. We should come up with the answer 0. And the last example is 7 raised to what power equals 7? What would my exponent be here? 7 raised to the second? No. 7 raised to the 0? No. But 7 raised to the first would give me 1. If I go to the next screen, here gives me the basic properties of logarithms. And this is for any base. It doesn't matter if it's 2, 3, 0.5, whatever. Log base b of 1 equals 0 because anything to the 0 power equals 1. Log base b equals 1 because b to the first equals b. Log base b of b to the y equals b because b to the y equals b to the y. And b log base b to the x is equal to log base b to the x equals log base b to the x. Then we have the properties of common logarithms, which basically are exactly the same, except they're called common logarithms because they are all base 10, and they are all what most calculators are in. If you look on your calculator and you have that log button, that is a base 10 button. And these read exactly as your previous rules read right there. Then we have the basic properties of your natural logarithms. And these are what are called base E. They are denoted on your calculator by ln for natural logarithm. And E is a number that is similar to pi, and it is approximately 2.718. And it is used in the banking industry. They use it to find interest when it's compounded continuously. It's also used in the insurance industry. And once again, your rules are pretty much exactly the same as they have been on the previous two screens. So here we are, we're going to try evaluating some more logarithmic and exponential expressions. This time, most of these are in base 10. If you note right here, they don't have a little base right there. And if they don't denote a base there, they mean base 10. So they're asking you, 10 raised to what power equals 100. And base 10 is easy. You count the zeros. How many zeros are there? 2. So my answer is 2. This one is a little trickier. 10 to what power is the 5th root of 10? Well, this is my numerator. This is my denominator. So my answer would be 1/5. 10 to what power equals 1 over 1,000? Well, because we have it on the bottom of a fraction, we know that. What kind of exponent does it have to be? Did I hear negative? That's correct. And then once again, I can count my zeros. I have 3, so my answer would be -3. Now I threw in a few natural logs. Answers are going to be very similar. It's going to be e to what power equals the square root of e. The square root of e is the same thing as raising it to the 1/2 power. So my answer would be 1/2. This next one is the one that trips a lot of people up for some reason. So if you just write it like this, e raised to the what power equals e to the 5th, you can pretty easily see that it's going to be 5. The answer is in the question. And e raised to the natural log of 4 is the natural log of 4. And this concludes our presentation on evaluating logarithmic and exponential functions. Thank you.